Once again, welcome back. My name is Mwiza Chirwa. In this video, we're going to work on another topic that is acid and base. I'll take you through acid and base. It's also another topic in chemistry. So by the end of this lesson, you should be able to define the terms acid and bases, describe the properties of acids and bases. So quickly, we need to look at the definition of acid and bases, but for now, we are going to use simple definitions for acid and bases, where later on this definition can be improved. The definitions is based much on the level of the learners as well. It's limited based on the level of the learners to be specific, but when you go further, the definition changes a little bit. So to set the ball rolling, what is an acid? So we can define an acid in this way. It is a substance that increases hydrogen ions when dissolved in water. While a base is a substance that increases hydroxyl ions when dissolved in water. Types of acids and bases. So acid and bases are categorized into two based on their sources. We have organic acids and bases, that is natural acids and bases, and we have inorganic acids and bases, which are also known as synthetic. Synthetic simply means they are synthesized in the lab. They are simply made in the lab. While natural, it means they can be obtained from either plants or animals. So what are organic acids or bases? These are acids and bases found in both plants and animal materials. What are inorganic acids and bases? These are acids and bases formed from chemical reaction. They are formed by combining elements in the lab. So we have examples of some of organic acids and their sources. So the name of acid and where we can find them. We have citric acid. We can find them in lemons, limes, oranges, grapefruits, berries, malambe. Lactic acid, we can find them in cheese, sour milk. Tartaric acid, we can find them in tamarind, apple, grapes, as well as bimba. We have ethanoic acid, which you can find it in vinegar. Methanoic acid, we have ants, as well as stink bites from bees, nettle stings. Carbonic acid, you can find in cokes. You can also find them in lemonade, as well as other fizzy drinks like Flozen. You can find them. Tannic acid is found in tea. Ascorbic acid, which is vitamin C, can be found in strawberries, oranges, tomatoes, as well as grapes. So examples of inorganic or amino acid or synthetic acids, where they are found, the name and where they are found. We have hydrochloric acid. In short, we call it HCl. You can find it as dilute acid in the stomach. The stomach is able to excrete the acid for digestion processes. In chemicals that are used in cleaning metallic surfaces, usually are in detergents, you can find them. Then sulfuric acid, you can find them in car battery, fertilizer, as well as detergents. Nitric acid, you can find it in fertilizer. For example, ammonium nitrate, we have nitric acid, as well as explosive. Examples of organic bases. Organic bases, these are coming from plants as well as animal materials. First of all, we can have a solution of plant ash. That one is a base, as well as shiduro is also a base. Examples of inorganic bases. Now we can have magnesium oxide. Usually you can separate them into bases, which are oxides as well as hydroxides. So we have magnesium oxide can be found as antacid in digestion tablets. Usually they make tablets like milk of magnesia. We have also calcium oxide. You can find them in cement materials as well as lime. Sodium hydroxide in soaps, toothpaste, potassium hydroxide, detergents, ammonia, fertilizer, and cleaning fluids. Now we're going to look at the physical properties of acids and bases. The physical properties, these are properties which we are able to see. So first of all, they have a sour taste or a sharp taste. Acids have a sour taste or sharp taste. They are corrosive. When I'm saying corrosive, they can enhance lasting. They conduct electricity because when they are put in water, they are able to ionize and form ions. Acids have a pH less than 7. They change colors of indicators, such as litmus paper as well as universal indicators. The physical properties of bases now, they have a bitter or flat or no taste. They have slippery as well as soapy feel when they are attached. They have pH greater than 7. They conduct electricity in aqueous state, not in solid state. In aqueous state, they have ions. They are in highly concentrated. Bases are able to form corrosion as well as to enhance lasting. Chemical properties of acids. So here in chemical properties, we are going to look at three major chemical properties of acids. The first one, they react with metals to produce salt and hydrogen gas. So, for example, we have an equation here illustrating the formation of hydrogen gas and the salt. For example, we have sodium, which is a metal, is reacting with hydrochloric acid to produce sodium chloride and hydrogen gas. So we have the word equation and as well as the chemical equation, Na, sodium hydrochloric acid to form sodium chloride, which is a salt, and hydrogen gas. Same applies to the another example that we can use, zinc. This reacts with nitric acid to produce zinc nitrate, which is a salt, as well as hydrogen gas. Same applies to the last one. We have iron plus sulfuric acid to produce iron 2 sulfate, which is a salt, and hydrogen gas. So we have different equations. Now you already know how to come up with the equations. We have the reactants as well as the product. So when a metal reacts with any acid, these are the products that we expect. We expect to have a salt and hydrogen gas. So we have talked about the chemical property of acid. We have said it reacts with metal to form a salt and hydrogen gas. But how do we know that this is a hydrogen gas? Since we are scientists, we cannot just live with the assumption saying that all the gas that is being produced is hydrogen. We have to test it. So here we're going to go through how we can test the gas which is going to be produced if it is really hydrogen gas. How to test hydrogen gas produced in the reaction above, in the reaction which we have already gone through. So collect the suspected gas in a gas jar, open the gas jar and bring close the burning splint or light splint. This one we are bringing close after you have opened the test tube on the mouth. So if a pop sound is produced, it means the gas is hydrogen gas. But if a pop sound does not produce, it means the gas is not hydrogen. So why a popping sound? Why not other gases producing a popping sound? So remember, hydrogen, when it reacts with heat in presence of oxygen, it explodes. That's why you hear a popping sound, signaling that the gas which is being produced is hydrogen. Then the second chemical property is acid. They react with metal carbonate or metal hydrogen carbonate to produce water, salt, and carbon dioxide. So we can also have some equation to illustrate the reaction of an acid with a metal carbonate or metal hydrogen carbonate. So the first one, we have calcium carbonate reacting with hydrochloric acid. It will produce a salt, which is calcium chloride, then water as well as carbon dioxide. This is a word equation which can be also written in this way. We have calcium carbonate reacting with hydrochloric acid to produce calcium chloride, which is a salt, H2O, which is water, and CO2, which is carbon dioxide. as well as sodium hydrogen carbonate and hydrochloric acid can react to produce sodium chloride, which is a salt, water, as well as carbon dioxide. So this is a metal hydrogen carbonate, or this one is a metal carbonate, but the products are the same. We have a salt, water, and carbon dioxide. Then the last one, we can also use copper carbonate. Copper carbonate, this one is a metal carbonate, can react with a dilute acid. Why dilute? If we react with concentrated one, the reaction can be very explosive. That's why we're using dilute here. We have the product to be a salt, copper sulfate, water, as well as carbon dioxide. This one can be illustrated by the chemical equation here: copper carbonate reacting with sulfuric acid to produce copper sulfate, which is a salt, water, as well as carbon dioxide. How to test now presence of carbon dioxide, which is going to be produced when an acid react with metal carbonate or metal hydrogen carbonate. Remember, I've said that when an acid has reacted with metal hydrogen carbonate or a metal carbonate, one of the product is a gas known as carbon dioxide. So how do we test that this gas is really carbon dioxide? So put a solution of calcium hydroxide in a test tube, and when you put a solution of calcium hydroxide in a test tube, then you add hydrochloric acid. When you add solution of hydroxide, of course here it is not written, a gas is going to be produced. Then you collect that gas which is being produced and introduce the gas into a test tube. You collect and put it in a test tube. Then when you put it in a test tube, then you are going to take that gas which you have collected from the reaction when you put solution of calcium hydroxide in the test tube. So here is just a short form, but we can align it more properly by saying that, for example, since you are looking at the reaction between an acid and metal carbonate, so you put a solution of calcium hydroxide into a test tube. Then from there you add an acid. There will be a reaction where you're going to form a salt as well as water and the gas. So you are going to collect that gas. So if you collect that gas, you're also going to have another test tube containing calcium hydroxide solution. So you're going to introduce the gas which you have collected into calcium hydroxide solution, like this one. This is calcium hydroxide solution. When you introduce the gas here, which has been collected from the reaction, we expect some white precipitate formed. That's why I'm saying that carbon dioxide react with calcium hydroxide solution to produce a white precipitate on the calcium carbonate. So here it is going to change the complex of this calcium carbonate solution and form a white precipitate. If carbon dioxide is bubbled through lime water, calcium oxide or calcium hydroxide, simply lime water, when carbon dioxide is pumped there, it turns into milky cloudy white. So the milky cloudy white is this one. You can see at first it was like this one, that is lime water contain calcium hydroxide. So when carbon dioxide dissolves here or bumped into this one react with carbon dioxide and form white precipitate. So the reaction, the mixture will look like this one. It will turn into milky or cloudy white. So that is how we can test the presence of carbon dioxide. So the other one is that it can react with base to produce salt and water. This reaction is known as neutralization reaction. So that's why we're saying that the reaction between an acid and a base is known as neutralization reaction. What is neutralization reaction? It's a type of reaction in which a base neutralizes an acid to produce salt and water. For example, we have hydrochloric acid, which is an acid, reacting with the sodium hydroxide, which is a base. We're going to form sodium chloride and water. So in all cases, when a base reacted with an acid, there are two products which are going to be formed. We have a salt as well as a water. So here sodium chloride is a salt, while here we have water. So this is a chemical equation, just illustrating what is happening in the world equation. So we have sulfuric acid can also react with sodium hydroxide to form sodium sulfate and water. This sodium sulfate is a salt, as can also be illustrated here. Now let us look at how we can do the neutralization reaction, because we have seen that one of the products is salt. So it can also be used in salt preparation. So let us look on a quick exercise. The question is saying that describe how neutralization occurs. So in this one, we're going to go through it together. Later on, you can also describe it in your own way. So procedure, we need to set up the figure as shown. So we need to have a clamp stand which is going to hold the bullet. So here we have a bullet, we have a conical flask, and we have some solution here. So we need to set up like this. We have a conical stand here. The diagram is just showing like this, but we need to have a clamp stand which is going to hold the bullet, so that for easy moving of the solution from the bullet into the conical flask. From there, you fill the bullet with hydrochloric acid up to 0 mark. Measure 20 ml of sodium hydroxide solution and pour it in a conical flask. To that one, you are going to add 2 drops of phenolphthalein indicator to sodium hydroxide solution in the conical flask. Open the tap gradually or slowly. Tap on the bullet to allow the acid to come drop by drop. Swivel the conical flask as the acid is coming out. Close the tap on the bullet when the color changes. So whenever you add 2 to 3 drops of phenolphthalein indicator in a conical flask containing sodium hydroxide, automatically the color will change into pink or purple. So as you are adding an acid, whenever you see color change, the pink color disappearing into colorless, it means now you have reached the end point where a base has completely neutralized an acid. That's why I'm saying that when the pink color changes to colorless, it means the base has completely neutralized an acid. That is the end point of the reaction. So it means in that particular conical flask, you have salt and water. So we can also obtain salt from that mixture. We can just use evaporation method, where we are going to pour the solution in a evaporating dish. Then we have source of heat here. When you heat, the water evaporate, we're going to remain with the salt. Now we're going to look at the uses of acids. So we have several uses of acids. It doesn't mean that these ones are the only ones. We can still find more about the uses of acids, but some of the ones which we are familiar much are these ones. Vinegar, which we always used in our relish. That's why we are saying that vinegar contains about 6% of acetic acid. It is used in food preparation. That's why I was saying there is most of the food, when you're preparing, you add vinegar and preservation as well. We have citric acid. It is used in preparation of investing, salt, as well as a food preservative. So it is also used as a food preservative. Then we have tannic acid. It is used in manufacturing of ink and in processing leather. We have acetylsalicylic acid. This one is used in preparation of drugs, such as aspirin, which can be used to relieve pain in our bodies. We have ascorbic acid, which is used as antioxidant. Now, let us look at another buzz session. So in this buzz session, we are supposed to answer these questions. Firstly, state 2 uses of acids. we can come up with the uses of acids based on which one do we prefer. Then we need to complete the following reaction. We have an acid here, a base. What is it going to come out from here? So here we have an arrow. An arrow indicates that we need to come up with the products which are going to be formed when an acid and a base react. So we have an acid here, sulfuric acid, reacting with calcium carbonate. What will be the product? The other one is define neutralization reaction, state 2, sources of lactic acid. So to find more about the lesson that we have covered in this video, we can differ from the resources which have been aligned in the reference. We have Excel and Succeed Junior Chemistry Book 2, and Achievers in Chemistry Book 2, Django in Chemistry Book 2, as well as Target Chemistry Book 2. So for the photos which we have used in this video, we also have some links which we can also Google and find more on the resources. But in this video, we have covered much on the definition of acid and bases. We have looked at the types of acids and bases, which we said we have organic as well as inorganic. Organic, we are referring to acids which can be obtained from plant as well as animal materials, while inorganic, these are acids and bases which can be synthesized or prepared in the lab by combining elements. And we have looked at examples of those organic acids, inorganic acids, organic bases, inorganic bases. And we have looked also at the properties, both physical as well as chemical properties. So this is the end of the presentation.